Hello, my dear students. Here is the lecture on continuous time convolution. Convolution is a property that commutes or multiplies two different signals of continuous time signals. So, in this lecture, we will learn about how the operation of convolution really occurs and how that can be convolute two different continuous signals. So first of all, there is definitions of components and keywords. Convolutions of two signals means if xt is a signal and ht is a signal, they can be convolved. So the sign of convolution is just a sign of asterisk or multiple sign. As you can see here, there is an asterisk sign, or there is the sign of asterisk or multiple sign. And for this, these signals are the output of the signal. This is the output of the signal. That is the convolution of the two signals, and that is the mathematical expression of the convolution of the two signals. That is uh, integration to minus infinity plus infinity. If there is a time limit, the limit will be brought into the limit part minus infinity plus infinity, and x tau ht minus tau d tau. So this equation we have to keep on our mind. This equation is pretty much important, but we have to keep on our mind this equation. That is the basic equation, and the main mathematical expression is that to compute the convolution, we have to keep on our mind that t is this t and that t are quite similar, because this t, I will highlight this t, and that t was similar, but there is a different tau, that is tau and that is tau, and the total integration is dependent on d tau. So that is the basic definition of convolution system. So we have to work out a master layout, that how a convolution really works. So there is a master layout of convolution. So there we have taken two signals. You can see there is a square signal with value of 2, and that is the convolution sign. We have to convolute this signal to the gt signal, and gt is the ramped signal. Here is the ramped signal that we can see here. We have to convolve two signals with each other, and that is the output of the convolution that you can see here. That is the output of the convolution, that how we can calculate and how we can get this signal. Clearly we will learn part by part. So first of all, we have to see what is the mathematical function of these signals. Ft equal to 2, that means it's a unit signal, so that is ft equal to 2, and minus 2 to 2 signal, that is the minus 2 to 2. In that part, 2 is the major 2 is the main value, so that is the signal. And there is gt minus t plus 1, and you will get this ramp function here, and the bounded value of this t is 0 to 1. If you put 0 here, this plus 1 here is the plus 1. If you put 1 here, the 0, that will be 0, that will be 0 at 1, 0 at 1. If you put 0.5 here, 0.5, so that will be 0.5 minus half, plus 1 means plus half, so in that particular point that you can get this. So this equation governs, and we will get this kind of figure and graph. So that is the mathematical expression that we have to calculate with that kind of equation. So that is the main thing. Now the main part of this thing is that now we will just look at the processes. So the first point in dt has to appear before the figures, then the blue figure has to appear. So that is the instruction of the animator, and text to be displayed, that is the text to be displayed, and there is the dummy variable tau, and this variable that has been governed by this. So this is yt that we have seen before. So we have to find out ft convolve gt. So in the next part, we get the next step, that is the first step. The second step, when we got into the second step. Now you get this. First of all, we have to make sure that we will travel through to the first signal to another signal. So how that can be traveled? So first of all, we have to find out f tau. What is the f tau? What is f tau? Okay, f tau and the reversed version of g tau, and g minus tau is shown. The shifted version of g minus tau is shown. Okay, what is the shifted version and what is not? That is the basic equation. If you put here g tau and it is f t minus t tau, that is g tau, that you can put here also. That's the thing, f tau into g t minus tau d tau. Okay, so in that part of mathematics, you have to put this thing, g t minus tau. What is t minus tau? Just take tau as a time that has been delayed. T is a common tau, t is a common time, and tau is just a time shift. So first of all, get g minus tau. What is g minus tau? If that part of a portion that was g plus tau, and the reverse function of it is g minus tau, that you can get here. And then after that, you have to calculate it by delaying it. That is g t minus tau. Why? That is minus 1 plus t plus that is t. Just take this value here, that is a different value, g t minus tau. That means t times shifting. And why that is drawn here in the minus side? Because as you can see, that is minus tau, and we have been adding the t here. That means that is plus t has been added here with minus tau. This part is known as time advance, so that will be time advanced. So if that point is 0, so after adding t, that will be t. T is a reference time. Okay, so that will be t shifted, and t is plus, so is plus shifted advance. Then that is minus 1, so plus t minus 1. Here is minus 1 plus t, you can see. So this signal shifts to the left. Okay, first of all, we have to do this. Then we have to convolve each other, and this is not, now this is f tau. We take the ft as f tau, but the small t is a small time shift. Tau has been replaced in the t. Okay, now in the next step, now that will travel through this. First of all, stage 1, calculation of yt in 5 stages. We have to calculate it in 5 stages. Okay, calculation of yt, how that can become. First of all, we give the shifted value here. Okay, then we have to take some bounded input output values. What is bounded input output values? You get here, there is two boundary conditions, minus 2, plus 2, 0 and 1. While calculating these things, you have to first of all take what is the highest limit of the margin. Minus 2 is the highest limit in the negative margin, plus 2 is the highest limit in the positive margin, but that falls below, that falls under this. No. This value has been fall under this, minus 2 to 2. So highest value is minus 2, lowest value is plus 2. But that will not done, because we have to add these 2 to calculate the maximum minus 0 plus minus 2, that means minus 2. 2 plus 1, that will be 3. So the new limit will be now that will reach towards this minus 2, and from minus 2 to 3, because 1 has been added with the value of 2. Okay, then that will give us some conditions. So first of all, when we just take this thing, stage 2, stage 1. What is stage 1? In that stage, we have to take minus 2 less than t less than minus 2. That means the last value of our range